Hello everyone and welcome. Today we're going to resolve LeetCode daily problem number 2179. Count good triplets in an array. So it's a hard problem in which we are given two indexed arrays, nums and nums1 and nums2 of length n, both of which are permutations of 0 of n, 3 dots, and -1. So a good triplet is a set of the distinct values which are present in increasing order by position both in nums1 and nums2. In other words, we consider post 1v at the index of the value v in nums1 and post 2v at the index of the value v in nums2. Then a good triplet will be set of x, y, and z, where 0 equal or less than x, y, and z, and also their combination x, y, and z, less or equal to n minus 1, such as position 1 of x less than position 1 of I and position 1 of z, and post second x less than post second y and less than post second z. So we need to return the total number of our good triplets. So we return count and we declare at the top count equal 0. Here's an example. We have nums1 which equal to 2, 0, 1, 3 and nums2 which equal to 0, 1, 2, 3 and output 1. So count only 1. Here's explanation. There are triplets of x, y, and z such that position 1 x less than position 1 y and position 1 z. They are 2, 0, 1, 2, 0, 3, 2, 1, 3 and 0, 1, 3. However, out of these triplets, only the triplet 0, 1, 3 satisfies second condition. Position 2 x less than position 2 y and position 2 z. Hence, there is only one triplet. So we can approach this as a good story. Once upon a time, in land of permutation, there were two magical arrays called nums1 and nums2. Both arrays are special because they are completely full of numbers from 0 to 1 minus to n minus 1. So imagine each number represents a unique character from a storybook. Our hero needs to form a trio, a group of 3 different characters that appears in correct order in both arrays. But what does correct order means here? For any 3 characters, x, y, and z, there must appear in increasing order in both arrays. In other words, in nums1, the position of x comes before y, and y comes before that. And in nums2, the same rule applies. X comes before y, and y comes before that. Our challenge is how many good triplets x, y, and z can be found that follow this rule. So to solve this, we can use a nested transformation. First, we note when each character appears in nums1, then we translate nums2 so that instead of characters themselves, it shows the position from nums1. Now our new version of nums2 helps us quickly check if the order is maintained. If the position now numbers are increasing order, the triplet is good. But there's more. We then process this new array backward using sorted list, a magic toolbox that allows keep our numbers in order, so that we can count for each character the valid number of characters that can be placed before and after it to form a good triplet. And voila, we sum up all those positions to get the final count of good triplets. So first of all, as you understand, we will be using binary search with reverse iteration. So let's write our algorithms will be binary search that the structure that we will use are two. First of all, we will use array to map numbers in nums1 to its indexes. So array indices. And the second, the structure that we use sorted list. Let's make them separate. Here the idea is to maintain dynamic sorted list that allow us fast binary search. Alright, let's start with first implementation of our indices array and connecting them together. Indices will be equal to their position multiplied by len of nums1. Then we will write for loop advance in enumerate of nums1, and we make very simple indices of num will be assigned to I. Here we map number in nums I to its index, so we can transform num2. So let's move to second transformation. For I num in enumerate of nums2, we will use now nums1 of I and assign it the indices of num. So now num2 stored in nums1 represents the order of numbers in terms of their position from num1. After that, we will move to our binary search, for which we will need to implement array, which will be sorted list, and we will use iteration. So we will proceed the transformed array in reverse order from each number to determine the count of valid elements on its left and right in the transformed world that can form a good triplet. So we will use for I num in enumerate, we will use nums1, and we will make it the reverse array. Here we will first of all count number in array that are smaller than num. For that we will use array bisect num. The second step, we will start with our result assignment, and our result will be I forgot to assign in index. Yep, array, and our result will be y minus index, and we multiply it by using nums minus index. And lastly, we will need to add num to our sorted list for future comparison. Oh, our count. Yep. And it will make for our iteration in using binary search. So let's run it. It's passed good and submit. Oh, and it's pretty efficient in both runtime and memory. Okay, thank you for your attention. If you have any comments, idea, feel free to share them down below. And have a nice day. Bye.